Courses in the cement industry. Present to you. To the friends of courses in the cement industry. I hope to subscribe to the membership, so that we can continue to provide useful content. In this course we will detailed explanation. Maintenance for LOESCHE, raw material mill. Part 2. Table of content. Part 1. 1. Main assembly groups. 2. Maintenance. This section contains 1. Mill stand. 2. Mill body including lining. 3. Table. 4. Auxiliary parts for table. 5. Rocker arm. 6. Swinging out rollers. 7. Grinding parts and auxiliary parts for roller. 8. Roller. Part 2. 9. Lever sealing. 10. Spring assembly. 11. Cabinets. 12. Nitrogen, accumulators. 13. Ring pipeline. 14. Filling and bleeding. 15. Mill drive. Part 3. 16. Classifier. 17. Classifier lining. 18. Classifier drive. 19. Star feeder. 20. Water injection. 1. Main assembly groups. This raw material mill contains 1. Star feeder. 2. Rocker arm. 3. Swinging out cylinder. 4. Mill stand. 5. Classifier. 6. Mill body. 7. Roller. 8. Table. 9. Mill drive. 9. Lever sealing. Components of lever sealing. Visual check. 1. Attachment bolts of lever sealing parts. 2. Wear of lever sealing parts. 3. Proper adjustment of gaskets and bellows. Maintenance. 1. Change worn parts according actual wear. 2. Shift interval according to the specific wear behavior of the mill. Interval. Visual check weekly. See this photo and video. Demonstrates components of the lever sealing inside and outlet. Function for lever sealing. 1. The adjustable strips create labyrinth gaps between the moving and stationary parts. 2. The gaps prevent dust penetrating to the externally mounted sealing strips. Maintenance for lever sealing. 1. Maintain the smallest possible gap between the stationary and the moving parts. 2. The rubber strips must always be sandwiched between two steel strips. The rubber should project only 2 mm in front of the metal strips. Larger projections mean that the rubber will be bent backwards and forwards and will break due to fatigue. 3. The two-part armor ring should be replaced when it is worn to avoid the sealing air system from becoming worn itself. 4. The armor plates of the sealing box should be regularly checked for wear. They should be replaced when worn before the basic parts of the sealing box also suffer wear. The armor plates are made of wear-resistant material. 10. Spring assembly. Visual check. 1. Attachment of clamping nuts. 2. Grease connections. 3. Condition of hydraulic connections. 4. Oil leakages. 5. Condition of bellows. 6. Condition of hydraulic cylinders. Maintenance. 1. Change bellows. 2. Check bearing clearance. 3. Change gaskets of hydraulic cylinders. 4. Shift interval according to the specific wear behavior of the mill. Interval. Visual check weekly. See this video about spring assembly. Function for spring assembly. The pressing force of the rollers on the grinding stock is generated by the hydropneumatic spring system. Maintenance. 1. The piston rods of the hydraulic cylinders are to be regularly checked for signs of corrosion, and treated with rust inhibitor if necessary. 2. Unions and screw connections shall be checked for proper seating at regular intervals. 3. Within the high-pressure area, materials may be used only satisfying the requirements for the 21A megapascal pressure stage. (11) Cabinets. Visual check. 1. Oil levels. 2. Oil flow, HSMS. 3. Oil leakages on cabinets and pipelines. 4. Discoloration of oil. Maintenance. 1. Change oil filters, air filters. 2. Change oil. 3. Clean tank. 4. Take oil samples for analysis. 5. Oil analysis every 3,500 hour. 6. Refer to lubrication instructions. Interval. Visual check daily. See this video. Demonstrates components of the cabinets. Function for cabinets. 1. HSMS. The hydraulic cabinet HSMS guarantees the oil circulating for the rollers of the mill. 2. HSLM. The hydraulic cabinet HSLM is the supply unit for the hydro-pneumatic roller spring system of the mill. Maintenance for cabinets. HSMS. 1. During the first 8 hours, following initial startup, each filter insert should be checked hourly, and replaced if found to be contaminated. After that we recommend a weekly filter check, and an exchange as necessary. 2. At the same time the air filters, at the far ends of the roller shafts should be inspected. 3. After 3,500 hours of operation, or at the latest after 1 year, empty all oil from rollers and cabinet. To remove oil sludge from the bottom of the tank, unscrew the rear inspection cover. 4. In case the oil does not circulate properly, check the suction lines and the return line sight glasses, for tightness as well as the oil temperature and viscosity. If the cool oil is too viscous, the only remedy is to heat it sufficiently, and to reduce the pressure setting of the flow limiting valve. See this video about HSMS. We follow together, maintenance for cabinets. HSLM. 1. The piston rods of the hydraulic cylinders are to be regularly checked for signs of corrosion, and treated with rust inhibitor if necessary. 2. Unions and screw connections shall be checked, for proper seating at regular intervals. 3. Within the high-pressure area materials may be used only satisfying the requirements for the 21A megapascal pressure stage. See this video about HSLM. In addition, the accumulator bladders may be destroyed. See this video about how to charge hydro-pneumatic bladder accumulator.
Designed to store and discharge pressurized fluid as needed. They are classified as pressure vessels. Hydro-pneumatic accumulators are charged with nitrogen, which is separated from the fluid by a piston, bladder, or diaphragm. There are risks involved when working with high-pressure gases and fluids. On no account must any welding, soldering, or any mechanical work be carried out on the accumulator shell. Work on systems employing hydraulic accumulators must only be carried out once the pressure in the fluid and/or the gas have been released. Hydro-pneumatic accumulators need to be pre-charged with an inert gas in order to work at all. Selection of the correct gas pressure is vital, as it defines the stored hydraulic fluid volume and pressure, which are important for the safe and correct operation of any machine. It is important that the correct gas pressure is maintained, and periodic inspection is therefore necessary. This gas used in hydro-pneumatic accumulators is almost always industrial-grade nitrogen. The use of other gases in these applications is dangerous and should not be considered. The nitrogen pre-charge pressure of an accumulator can only be assessed when it has been fully depressurized of hydraulic fluid. This means that the accumulator must be positively isolated from a live system and released of all hydraulic energy, or that the entire system has been completely shut down and fully depressurized, or that the accumulator is not currently connected to the system. For example, it is on a workbench. The HYDAC FPU1 Universal Charging and Testing Unit can be fitted directly to HYDAC diaphragm and piston accumulators, but it uses an adapter to connect to a bladder type accumulator. This is known as the A3 adapter. It is clearly stamped A3. The accumulator gas valve will be opened and closed by pushing the valve plunger down. This will be operated by the center screw of the A3 adapter. Due to the high pressures involved, this valve should never be opened by hand. Use only the correct equipment, that is, the Universal Charging and Testing Unit, and follow this process. Remove the plastic protective cap. Remove the metal seal cap. Ensure that the socket head cap screw of the A3 adapter has been wound back, so as to not immediately open the gas valve upon fitting it to the stem. After ensuring that the surfaces are clean, screw the adapter on hand tight. Before fitting the Universal Charging and Testing Unit to the A3 adapter, first ensure that the surfaces are clean and that the sealing O-ring has been correctly fitted. Align the spring-loaded hex drive to the screw and screw the universal charge head to the A3 adapter, hand tight. Ensure that the gas release valve on the side of the charge head has been closed firmly. It closes clockwise, like a tap. Before connecting a nitrogen regulator to a nitrogen bottle, ensure that the regulator will be closed by backing the pressure setting down, winding the adjustment counterclockwise. Make sure that the threads and seats are clean, and connect the nitrogen regulator to a bottle of industrial-grade nitrogen. Connect the hose in between the regulator and the universal test and charge head. Open the isolation valve of the gas bottle. Slowly turn the main spindle of the charge head clockwise until you feel a resistance to movement. From this point, back the spindle off about 1/4 of a turn. Begin the gas flow from the bottle to the accumulator by slowly raising the pressure at the regulator. When shipped, the majority of HYDAC bladder accumulators are charged to 2 bar. At this pressure, the bladder is inflated and is in contact with the inside of the shell, and there is little chance of damaging the bladder. However, if the bladder is new or has been deflated, you must ensure that the initial inflation is undertaken as slowly as possible, otherwise the bladder may stretch too quickly and rupture. You can assess whether the bladder has been inflated through checking the position of the fluid port poppet stem. If it has extended, The inflated bladder is pushing the poppet valve closed. The rate of nitrogen flow may be increased only once the bladder has been properly inflated. Raise the gas pressure in the vessel to the desired pre-charge pressure. Stop the flow of gas by backing off the nitrogen regulator fully. Small pressure changes may occur in the accumulator assembly with temperature changes. It is best practice to charge the vessel to a pressure slightly higher than what is needed. Allow the vessel to cool and then depressurize to the final setting slowly. Once the pressure is at the desired level, you can begin disconnection by winding the main spindle counterclockwise, then reclose the gas valve. The spindle has been fully wound back once a faint clicking noise is heard. Release the gas from the charge head and hose by opening the gas release valve in a counterclockwise direction. Once depressurized, you can remove the charge head from the A3 adapter. Then remove the A3 adapter from the gas stem. Use a leak detection fluid to ensure that no gas is escaping from the accumulator. Replace the metal seal cap, tightening it to 30 Newton meters. Replace the plastic protective cap. Close the main isolation valve on the nitrogen bottle. Vent the remaining gas out of the regulator by adjusting the pressure regulator up. You can now remove the hose from the regulator and the regulator from the nitrogen bottle. We recommend that the gas pre-charge pressure is rechecked the following week. If there is no gas loss observed, check again after 4 months. Again, if there are no losses observed, a 6-monthly inspection cycle should be sufficient.
13. Ring pipeline. Visual check. 1. Oil leakages at pipe fittings. 2. Check conditions on pipe support and clamp. Interval. In starting time visual check weekly, later monthly. See this video about ring pipeline. (14) Filling and bleeding hydraulic cylinder roller. Interval. 1. Bleed system monthly. 2. After oil change. 3. After cylinder or accumulator change. 4. Refer to LOESCHE filling and bleeding instructions. We follow together, filling and bleeding hydraulic cylinder roller. Thanks for following the channel, Courses in the Cement Industry. And please help us to continue and provide more information, by subscribe to the membership, and inviting your colleagues to watch this channel.